This video will be looking at the skill set comparing expected and observed frequencies, which is a skill that you can find within the chance topic for Year 7 Mathematics in the Central Assessment. So what I've got here is just a few examples that have been taken straight from the Central Assessment, and we're just going to tackle these few examples so you get some intuitive feel of the mathematics that's used within here. Now by now it should be noted that you're able to display probabilities in the form of fractions, decimals and percentages, and what we're going to do is we're going to utilize fractions in displaying probabilities in the form of fractions, and with the help of our scientific calculator be able to answer questions provided. So this question here, how many times would you expect a standard die to land on the number 4 in 12 rolls? So there are a few things we need to observe. A standard die, okay, so a standard die just has 6 sides. And when it says standard, it just means it's not biased. Every number is equally likely to land on it. There's no weight to it or any type of bias towards it, okay? And we want to know what's the likelihood of it landing on 4 if we were to do 12 rolls. Now it is an expectation, okay? It's just a prediction. It doesn't mean it's going to necessarily happen when we get our answers. It's just a prediction based on what probabilities we do know. And what probabilities we do know is that there is a 1 in 6 chance of this standard die rolling a number 4. There's a 1 in 6 chance, okay? And we're going to do 12 rolls. Anyway, so the amount of trials we're doing is 12 rolls. And what we do with these two numbers is we just multiply. Okay? So you will just get your calculator out, get the fraction button, put it as 1/6. Make sure you go across, okay? Because if you don't go across and you go straight into the times, it's going to put the times in the bottom there, and you don't want to do that, okay? So you want to make sure you go across, press times, and times it by 12. So we're expecting the number 4 to appear twice. Now whether this happens, you might get more or less, you might get none at all. But we're just making an expectation based on the probability that we have. Now think about it in this way. If I were to roll the dice 6 times, just 6, I'm expecting a number 4 to happen at least once, just once, because there are 6 sides to that die and there's a 1 in 6 chance of that happening. So if I did it 12 times, so I doubled the amount, I'll be doubling the expectation. So in this case, double 1 is 2, okay? The next question we're looking at, right over here, let's scroll down. How many times would you expect a standard die to land on an even number if you had 80 rolls? So again, the format is the same. We're gonna find a probability, okay, still a standard die. We're gonna find a probability. This time, the probability is an even number. So a standard die, again, it's gonna be out of 6. But how many even numbers are there? There's 1, 2, 4, and 6. These are the even numbers that you find on a 6-sided standard die. And of that, there are 3 of them. So there's 3 in 6 chance, also known as a half chance or 50% chance, okay? You can simplify this to half or leave it as 3/6. That's fine, because the second part, a number of trials of 80, is what's being multiplied by. And you can do 3/6 times 80 or 1/2 times 80 on your calculator. You will still be provided the same answer. Or in other words, what's half of 80? Now I know a lot of you will know that this is 40, but just to double check, 3/6, make sure you go across, times 80 will give me 40. So I'm expecting out of 80 rolls, 40 of them or half of them will be an even number, regardless of whether they're 2, 4, or 6. The next question, how many times would you expect the spinner to land on pink in 18 spins? Same format, find a probability and multiply it by the amount of trials. This spinner here The amount of pinks there are 4. And the amount of wedges there are all up, including those pinks, are 6. So there's a 4 in 6 chance of me obtaining a pink. If I multiply this by 18, because that's the amount of trials that we have, again, fraction 4/6, multiply that by the amount of trials, which is 18, and we get 12. So I'm expecting, after 18 spins, I'm expecting pink to appear 12 times. Again, it's just an expectation. It's not a true representation of how many pinks I'm going to get, but it's the closest thing to a prediction. The last 2 examples, are the trickier examples, looks at taking random samples and also giving you a multiple choice question. Okay, so this one here, a random sample of 5 counters has been selected from a container of 60 counters. Based on this sample, how many green counters would you expect to find in the entire container? Okay, so quite a long question here, and there's a lot of information to observe and to obtain, but again, just like the previous questions, the format's going to be the same. We're going to look for a fraction, which is in the form of a probability, and we're also going to find the amount of trials. The only thing that's different is that it's just worded in a different format. So right here, this is our sample. Okay, and the sample shows 5 counters, which it says in the question, 5 counters. And from here, the color of interest is 3. So from this sample, there is a 3 in 5 chance of obtaining a green. So 3 in 5 chance. My program is just getting a little bit laggy, if you couldn't tell. So just bear with me and bear with the program if you can. So there's a 3 in 5 chance. Now, this sample was taken from a container of 60 counters. So I am expecting, technically, I am expecting 3 lots of every 5 to have 60 counters. No, to be green, sorry, not to have 60 counters, to be green. So if there were 10 counters, okay, if there were 10 counters and we were to create the amount of counters again, okay, so there's 10 counters, it's predicted that this one here would be pink. I'm just going to write pink. This one here would be blue, and then this one, 3 here, would be green. So if there were 10 counters, I'm expecting all up there should be 3, 6. There should be 6 counters that are green. Remember, it's just an expectation from this random sample that we got here. But we're not asking for 10 counters, we're asking for 60. So what I did to get these 2 counters, to double the counters, is just I doubled the amount of green. So I just multiplied it by 2. Okay, to indicate there are 10 counters. The shortcut method is all you need to do is get your fraction and multiply it by 60, and this will get you the answer. But all this is doing is we're getting our 60 counters. Okay, let's have a bit of an intuitive feel to this. We're getting our 60 counters, all right, and the sample of this was 5. So we're gonna split 5 counters, 5 counters, 5 counters, and we're going to keep doing this until we run out of counters, okay? And all up, there should be 12. There should be 12, because how many 5s go into 60 is 12. Okay, so we've got 5, 5, 5, 5, 5, 5, 6, and then another 3, 4, 5, 6, okay? So we've split the 60 up into 5s. Now, the sample that we got from this question was 3 of them were green, 1 of them was pink, and 1 of them was blue. So we're going to make the assumption that every single sample that we take out is going to follow this sample that we've taken. Okay, let's just assume this for now. So we have 12 of these samples that look exactly like this, okay? And from these 12 samples, in each sample, there's going to be 3 green, yeah? So there's going to be 3 in here, 3 in here, 3 in here, and 3 in every single sample for all of these 60 counters. And then what you have to do is, you got to just count out, how many greens are there? Well, if we're predicting 3 in here and 3 in here, we're just doing 3 times however many sample lots we got, which was 12. And 3 times 12 is 36. So from this sample here, we're expecting 36. And another way of getting that is just by doing this onto the calculator. But I wanted to show you the behind the scenes of what's actually going on. We're just taking these samples, we're mimicking the sample that we've been given here, splitting it up until we run out of counters, and then just predicting, there's going to be 3 in here, 3 in here, 3 in here. If I do this into the calculator, 3 over 5 times 60, we'll get our answer of 36, which is what we expected in the first place. So my answer here is 36. The last question, which spinner would you expect a frequency of 6 pinks for every 12 spins? All right, so what's this asking? Let's just say you were given this little spinner, and they had 2 pinks, a green, 2 mustards, I guess, and 1 blue. And they said, okay, spin it 12 times. And you spin it 12 times. I'm expecting from those 12 spins to have 6 pinks. Okay, so I'll do it to this one. I'll spin this one 12 times, I'll spin this one 12 times, and I'll spin this one 12 times. And 1 out of these 4 different spinners will give me just an expectation of 6 spins based on probability, okay? And so what we need to do is we need to find out the probability of getting pink for each spinner and then multiply it by the amount of trials, 12, which is like we did in the previous examples. And then for one of them, our answer is going to be 6. So let's work this out. This one here, we have a 2, and how many colors are there? There is a 2 in 6 chance. So it's 2 over 6 times 12. This one here is a 3 out of 1, 2, 3, 4, 5, 6. A 3 out of 6 times 12, or half of 12. Well, half of 12 is 6, which is the answer. Let's just double check. We might have this as our correct answer. In this one, we have a 2 out of 1, 2, 3, 4, 5, 6, 7, 8. 2 out of 8, or 1/4 times 12. And this one here, we have a 4 out of 6 times 12. And just to make sure, because I think we might know our answer, just to make sure, we'll get the calculator out. We'll go 2 over 6 times 12. This gives us 4, so it can't be this one. 3 over 6. Okay, there we go. 3 over 6 times 12 is our 6, which is the answer we're expecting. Let's just make sure. 2 over 8 times 12. So we're expecting 3 pinks from this spinner here, and 4 over 6 times 12 is 8. So this here has to be our answer based on getting 6 pinks. And this concludes the video for this skill set. Go ahead and attempt this skill if you haven't done so yet, and I'll see you guys in the next video. Bye.